Hello everyone, and welcome to another GIS statistics lecture video. And in this video, I want to talk about a different approach that we can use to analyze point pattern distributions. In specific, now I want to start to talk about ones that deal with distance. Right. In specific, right, Euclidean distance. So if you're unfamiliar, right, distance in terms of Euclidean, right, it's equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. All right, so this right here is Euclidean distance. The y's and the x's are just the coordinates of the points that you're dealing with. All right, so this is Euclidean distance. So this is going to be very important as we talk about stuff. But for right now, what I want to do is I want to talk about the first sort of method that we can use that incorporates distance to try to figure out or hint at the distribution of the underlying data set. And so we're going to talk about something called the first order analysis. And the first order analysis deals specifically with this idea of nearest neighbor. Right. So the nearest neighbor, in case you aren't familiar, is basically the 2 points, or I guess I should say the point that is closer to another point than any other. So put another way, right? Put another way, right? If we have a couple of points, right? If we have a couple of points, right? The nearest neighbor is basically, the nearest neighbor of this point is going to be whatever point, right? This distance is the shortest between. So in this case, right, the distance from here to here is a lot shorter than the distance from here to here. So this distance would be the nearest neighbor distance. This would be the nearest neighbor distance. And I'm going to use NND, nearest neighbor distance. Hopefully that makes sense because this is kind of an important concept. Again, the nearest neighbor, right, is the distance to the closest point from that point. So how does a first order analysis actually work, and what is it actually doing? So you can imagine we have a data set. And for that data set, the first thing that we're going to do is we're going to calculate the nearest neighbor distance for every point. Right, calculate the nearest neighbor distance for every point. Right, again, going through each point, figuring out how far away it is to the closest other point, storing that information. Right, step 2, we're going to pick some distance. I'm going to call this distance r, or radius. Right? Then count the number of points whose nearest neighbor distance, right? Whose nearest neighbor distance is less than r, right? So hopefully this makes sense, right? We're going to pick some arbitrary distance and we're going to compare for all of those nearest neighbor distances. If it's less than r, we're going to count it. If it's more than r, we're not. Step 3, divide the result of step 2 by the total number of points. So what I want to do is I want to talk about what these two things are doing, or what this means, right? When you do this, and then you divide by the number of points, what you're essentially calculating is the probability that if I were to pick any point out of the data set at random, that its nearest neighbor would be within this distance that we've picked here. Right? So this is the probability that a random point will have distance less, will have nearest neighbor distance less than r. And this is going to be very important for how we interpret the end result of this thing. Step 4, we increase r, right? We increase this distance and redo steps 2 and 3. Right, so we increase the distance, we count the number of points whose nearest neighbor distance is less than this newly increased distance, and we redo steps 2 and 3. So we're calculating, now we have a slightly bigger r, and we're calculating the probability that a random point will have a nearest neighbor distance less than that r. Okay. So step 5, right, is plot the results. So let's really quickly look at what this would look like as an equation. Right, so again, keeping in mind that this is the general idea. Right, let's just quickly recap. Right, the general idea is that we're trying to figure out the probability that if you pick the point at random, that its nearest neighbor would be within some distance that we've described. And we're doing that for a lot of distances, and we're going to plot the results. Okay. So what does this look like as an equation? Well, let's think about what we said. What we want to do is we want to have an equation that will take in a distance. So we'll call this equation G, that will take in a distance. We'll call that distance D. Actually, let's call this distance R, right? This some radius distance that we have. Right? And what we want it to do is we want it to sum up from 1 to m, where m is the number of points. Right? And then we're going to see this notation that that you may not have seen before. This right here, and it takes in two things. It's going to take in d sub I, and r. So what this is doing, right, we're going to blow this out. What this is doing is this is going to internally compare, and it's going to say if d sub I is less than r, right, it's going to be 1. And if it's not, if it's greater than 1, it's going to be 0 otherwise. Right? So this right here, this is that comparison. This is that what we said before. We're saying, for a point, is its nearest neighbor distance less than r? If it is, count it. If not, don't. Right? And then we said the next part was to divide by the number of points. So that's the same as multiplying by 1 over, right? So this equation right here, this is the exact same thing as steps 2 and 3, right? This equation, this equation right here, This is the same as picking some distance and counting the number of points that are less than it, and then dividing by the total number of points. So that's what this is doing. So then we would then run this equation again with an increased distance of r, and we would plot the output. So let's go ahead quickly and let's look at what this would look like. So we're going to talk about a graph. So graph, we have two axes, right? On the x-axis, right, this is that distance, right? This is that r distance that we talked about. So this is how far away, or what is the maximum distance we have between 2 points for them to be counted. And then this is that probability, right? So this is, again, the number, this is how likely is it that a point chosen at random is going to have its nearest neighbor be within this distance. Okay. And so what you would see is something like this, where when the distances are really small, right, not a lot of points are going to have their nearest neighbor distance be smaller. But as you increase the distance, right, more and more points are going to come online. And then you're going to reach some distance, well, all of them are, right? All of the points are going to have a nearest neighbor distance less than r. Right? So this is kind of the output that you're going to look at. So we can sort of assume a standard deviation, or we can assume some value. So what I want to do in the next video is I want to actually go through some actual graphs and show you what they look like and how we can interpret them. But again, what I'm hoping you get away with right now is that this equation tells you for a given distance, what is the probability that a point chosen at random will have its nearest neighbor be within that distance. And when you graph that, right, it's saying as we increase that distance, right, how does that probability change? I know there was a lot in this video, so if any of this was confusing, I encourage you to pause the video, go back, rewatch the part you're confused about, and as always, please reach out. Thank you.